test review right now? Like we're doing problems?
Yeah, I'm going to do problems from your homework for the test review. So on the homework one that you did, the trig homework 1, I'm going to do number 4. Alright, so it's going to tell you to find all 6 trig values for some angle. In this problem, it gives you negative 3 pi over 4. Alright, in this class, okay, so, because you don't get a reference sheet on the ACT or the AP test.
We don't.
No. So the cosine of this angle is, all you got to do is look at the x value. That's all you got to do, and then write down the x value.
Okay, cosine of x.
Sine is what?
Rise up.
Right, then the tangent is alright, and that one's equal to 1. Is anybody confused on where I got any of those numbers from? Alright. So then the cosecant, alright, well then those other 3, the cosecant, secant, and cotangent, you just flip them. You don't even have to rationalize them on this test if you don't want to. You can. If you get it wrong, though, we'll mark it wrong.
Wait, so what was the rule? You can't put the...
When we flip these, some of you on your when you did your homework, when you flip these, like secant goes with cosine. Alright, so 1 over cosine, all I do is flip that. This means I flip it. So that's 2 over root 2. This is where the negative still goes with this fraction, but it doesn't matter where you put. I mean, you can put it on top or bottom, wherever. It's just got to have a negative somewhere. There. Does anybody have any questions on where I got any of these flipped from? You can rationalize the denominator there if you want to. That's optional. I don't care. But you do need to know how to rationalize it for the ACT. But we're going to do that. That's our next topic, like after we get back. 205, yeah. So this problem, you'll have one problem like this on the test. It'll tell you to use the period as an aid. All you've got to do is take the top number, alright, and divide it by the bottom number. And all I care about is the remainder. I don't care about anything but the remainder. I'm going to make the remainder is going to be my new numerator. Alright? So 2. So, everything's the same. The pi's still there. The 3's still on bottom. There's still a negative sign. The only thing that changed, the 8's going to change to a 2 because that's my remainder. Does anybody have any questions on this? Alright, but we're not done. You still have to tell me the value of negative 2 pi over 3. So I look at, find 2 pi over 3 on the unit circle, but it's negative, so I have to go backwards.
So you just subtract 6 minus 1.
Yes.
So
Okay.
So
So I need to, so that's the same thing as, negative 2 pi over 3 is the same as negative 120. And negative 120 is 360 minus 120, which is 240. So I want to look at 240 degrees. What's the y value at 240 degrees? And it's negative root 3 over 2. Our triangle is always going to be, it's always going to start from the origin. Always start from the origin. I'm going to come out in quadrant 3 because this is quadrant 3. Then when I connect my point, the triangle, to one side or the other, I'm not going to connect it back to the y-axis. I've got to connect it back to the x-axis.
Is that for like...
That's every triangle. Any quadrant, you're going to connect it back to the x-axis. So there's my triangle that I'm looking at. Now I'm always going to look at the angle that is closest to the origin. That's always the angle that I'm looking at. Does anybody have any questions about that? How to draw the triangle? Now this is where the SOHCAHTOA comes in. You won't get SOHCAHTOA on your test, so you're going to have to, that's not going to be there. So you're going to have to know SOHCAHTOA. Cosine is equal to adjacent over hypotenuse. So the adjacent side is equal to -4 because it's on top of the fraction. The adjacent side on these problems are always the side that's on the x-axis. So whatever side's touching the x-axis on the triangle problems is going to be the adjacent side. Then the hypotenuse is always the side that comes out.
Because cosine equals x.
Yes. That's how you can remember it as well. So then the other side is going to be a triple. You should just know that it's going to be 3, but it's -3 because it's below the x-axis.
I should put just
It's a Pythagorean triple.
Can you just do Pythagorean theorem?
You can, but by the end of the year, there's going to be 5 triples I expect you to know.
Opposite over hypotenuse.
Opposite over hypotenuse. The opposite side's 3, or -3, over the hypotenuse, which is 5. Is anybody confused on where I got that from? Then the tangent, TOA, T-O-A, is opposite over adjacent. The opposite side's -3. The adjacent side's -4. So if I have a negative over a negative, it's a positive 3 over 4. Positive 3 over 4 because they're both negative. Just like in the third quadrant on the unit circle, I have positive tangents in all the third quadrant value angles on the unit circle. Alright, so now all 6 of them. So, but they're even easier than the other one. There's no you don't have to rationalize them at all. So secant goes with cosine. And cosine was up here at the top, it already told you, so it's going to be what? Alright. It doesn't matter where you put the negative sign as long as you put it somewhere. You don't have to. You can keep it with a 4, but -5 over 4 and 5 over -4 is the same thing. Cosecant goes with sine. -5 over 3. And then cotangent is just what? 4 over 3. So does anyone have any questions on any of this? Alright. So what we need to do first is break down the number, the 54. It breaks into 9 and 6, which in turn breaks into 3 and 3, and 3 and 2. Now since it's a square root, I don't have a 2 there at all. I don't have a 2 there, I don't have any number there, so I just assume that it's a what? A 2, because it's a square root, so that means I need pairs. I got a pair of 3's there, but the 3 and 2 are left over. So when I first started doing this, I go ahead and make me a square root so I can put stuff under it if I need to. Alright? I have a 3, since I have one pair of 3's, one 3 is going to go outside the radical. The 3 and the 2 are left over, so yes, I'm going to multiply them together and stick them back under the square root. So that's going to leave me with a 6 underneath. Is anybody confused on where the 3 or the 6 come from or where I got them from? Alright, that's what we're doing next. Alright, so the letters is a little, it's not super difficult, but it can be a little tricky sometimes. Alright, all I need to know is that since I'm doing a square root, I'm going to divide each exponent by 2. So 4, the exponent of the x is 4. So I'm going to divide 4 by 2.
So it'd be x to the second.
You're right. So, and whatever I get when I divide 4 by 2 is going to be my exponent of the x on the outside number.
And if you have a remainder,
And there's no remainder for x, so there won't be any x's underneath the square root.
Then there's 1, it's going to be y squared.
Right. Y to the 5th, I have to divide 5 by 2. 2 will go into 5 twice. So that's y squared's on the outside of the radical. I have a remainder of 1. So 1y will go on the inside. You can put y to the first if you want to, but it's not necessary. Right, then z has an exponent of 7. 7 divided by 2 is 3. Has a 3 with a remainder of 1, so there'd be 1z on the inside. And there's your answer. Cube root, we do the same thing. We start with the number and break it down. That's terrible. So that's 9 and 6, 3 and 3, 3 and 2. Except now that this number is not, it's there, it's a 3 now, it's a cube root. That's what that means. Instead of a pair of 2's, I need to pull out a set of 3. So I have to have a group of 3 before I can pull it out of the radical. Now when you write your answer, you need to make sure that you include this 3 with the radical on your answer. So I know that you know what we're talking about. I don't know. There's one like this on the. It's not exactly like this on the homework. There you go. All right. So, and I have a 2 left over. One group of 3. I have one set of 3 here. That means I'm only going to have 1 3 on the outside of the radical, and then a 2 on the inside. Right. All right. Then I've got to do the letters. This is where and the reason I picked this one for this reason. Right, I've got to divide each of these exponents by 3 instead of.
So it's just 1 exponent.
Well, can I divide 2 by 3? No, so it stays on the inside. The whole thing stays on the inside. If I can't divide it, if it's not big enough for me to divide it, it just stays on the inside. But 7, I can't divide 7 by 3. It goes in there twice. With 1 remainder, and you can choose to put the 1 there, or you cannot. So before I add and subtract, I need to break down every radical and simplify it. So 27 will break down into 3 and 3. One thing I would like you to remember, which we're going to do stuff you must know cold quizzes on it, is 3 cubed is 27. 3 to the 4th is 81. 3 to the 5th is 243. Those are things that will help speed up your ACT score.
3 to the 5th is 243.
Yep. So here I've already got a 4 on the outside. I have one pair of 3's. All right, so I'm going to have a 3 that I'm going to multiply there on the outside, and then I'm going to have a 3 on the inside. All right. Can I break down the 3 root 3? No. So I'm just going to bring it down. But I can break down the 48.
6 times 8 or 12 times 4.
Right. But here's another important multiplication table that it's not talked about a lot, but it's very common. 16 times 3 is 48. Shows up a lot at random places. I don't know why. But 16 times 3 is 48. That breaks down to 4 and 4. And this also illustrates another good point. If I break 16 down into 14 or 4 and 4, all right, I have a pair of 4's. I can stop right there if I want to, and just have a 4 on the outside, and I have a 3 left over. I got 3 on the inside. So I got to FOIL. I got to multiply the 2 first terms together. That's
2 square roots of 25, which the term is square roots.
Hey, let me explain. 2 times. All right, 2. You multiply the numbers in front together. You got to multiply the numbers in front together. So 2 times. There's not a number in front here, so just 2. Then the square root of 5 times the square root of 5. 1 big square root, 5 times 5. Then I got to multiply the 2 outside numbers. All right, it's a positive times positive gives me a plus there. If one of these was negative, then it would change this to a minus sign. All right?
Which would be adding a negative.
Adding a negative, yes. All right? So that's going to be 4 times the square root of 5 times 2 plus. Now both of them have a number out front, so I got to do 3 times 2, which is 6. And then the square root of 2 times square root of 5 is 1 big square root 2 times 5. Then I've got to do this last step, which I didn't draw there.
Add them all together.
Then the two last numbers. Square root of 3 times the square root of 2, 3 root 2 times 4 root 2, which is 12
Root 6.
root 2. Do what? Because I didn't have enough room to write it. Alright, so now I need to go back and simplify. Alright, I have a pair of 5s, so I can carry that 2 out and bring a 5 out.
When did you do the inner?
What?
3 root 2.
Alright. 4, I can't pull anything out of the 5 times 2, it's just 10. Plus 6 times root 10. Plus 12 times, there's a pair of 2's under that square root, so I can pull a 2 out. Yeah, then I would, 10 plus, I'm going to multiply those out, root 10. Well, here, I can combine these because they're like terms, so that would be 10 root 10 plus 24. And then these are both numbers, so I need to add them together. It's 34 plus 10 root 10. Right.
Is that a 2 or an egg? I mean, 2 or a Z?
It's a 2.
The exponent, that's a 2.
Lines.
Yeah, I put lines through the Z's. Okay, so what this actually means is I've got 7 square root of 2x to the 4th, y to the 3rd, times 7 root 2x
That's what I thought you did, but I didn't know how to multiply that.
for y to the 3rd. Alright, well, I'll multiply the two front numbers together, which is 49. And then I would put all these under the square root, if you wanted to.
But
Right.
you could do 4, 8, 16, 1, 2.
Then you could combine all those, or I can say, look, I got a pairs of each of these. Like I've got a pair of this. If I treated this as one object, I have 2 of them. So if I have 2 of something under a square root, I can just pull it out. So that's 2x to the 3rd, y to the 3rd, which is 98. X to the 3rd. That should be a 4. This 4.
You're confusing us.
Just keep the exponents the same.
You did that incorrect.
That would be your answer.